Okay, today we're looking at the answers to the test 2 review. Question number 1 is I have a function f of x is equals to 3x cubed plus 4x squared minus 6. I need to find the derivative, f prime. The derivative entails first a multiplication. You multiply the coefficient and the power. 3 times 3 is 9. And then you subtract 1 from the power. So you guys subtract 1, 9x squared. And so I have plus 8x, and the derivative of a constant is 0. And so that's plus 0. I can leave that off. And that's my answer to question number 1. Question number 2, I have f of x is equals to 3x squared plus 6x minus 2 times negative 2x squared plus 2x cubed. You can use the product rule here, but it is faster to just FOIL it out and then take a derivative. And so that's what we do. And so that's negative 6x to the 4th power. Don't forget we're adding powers when we're multiplying. Plus 6x to the 5th plus these two right here. So that's minus 12x to the 3rd power. 6 times 2 plus 12x to the 4th power. And then I'm multiplying by negative 2. So that's positive 4x squared. And then negative 2 times 2 is negative 4x cubed. Now I group like terms. I have 6x to the 5th. I have a 4 and a 4, so that's negative 6 and 12 is 6. X to the 4th power. I have a 3 and a 3, so that's minus 16x cubed. And then I have a 2 plus 4x squared. Now I am ready to find the derivative f prime of x. Multiply 6 times 5 is 30, x to the 4. Multiply 6 times 4 is 24, x to the 3rd. Multiply 16 times 3 is 48, x squared. Multiply plus 8x. And there we have our derivative. Alright, number 3. I have a fraction. F of x is equals to 2x cubed plus 4x squared minus 5 divided by x squared. Again, you could use the quotient rule right here. Again, that's much harder. Instead, what you want to do is you want to move the x up and change its power. And so that would be f of x is equals to x to the negative 2 times 2x cubed plus 4x squared minus 5. I distribute the x to the negative 2. And so that's 2x plus 4 minus 5x to the negative 2. Again, we're adding powers when we're distributing the x to the negative 2. And then we take the derivative. So it's simple, f prime of x. And that's equals to, whenever you have an x by itself, you just drop the x. And so that becomes simply 2. The derivative of a constant is 0, so that goes away. And then I multiply and subtract. So that's going to be positive 10x to the negative 3. Be careful when you're subtracting. Negative 2 minus 1 is negative 3. And of course, I cannot leave the negative power. And so I write it as 10 divided by x cubed. That's number 3. Number 4. Lots of fractions in number 4. F of x is equals to 2 divided by x minus 3 divided by x squared plus 3. I have to take the powers up. So f of x is equal to 2x to the negative 1 minus 3x to the negative 2 plus 3. And then I multiply and subtract. F prime, the derivative is going to be negative 2x to the negative 2 multiplying, so that's positive 6x to the negative 3, and of course the derivative of a constant is 0. I cannot leave the negative powers, and so I rewrite negative 2 over x squared plus 6 divided by x to the third power. Number 5. I have a fraction. I have a radical, which will become a fraction. 3x to the 19th power. You first rewrite this as a fractional power. That is equals to x raised to the 19 over 3. If you're having a hard time, one of those strategies you can do it right here is looking at the original problem. You just put a /3 right here. This 3 becomes the denominator and everything else goes away. And so you're left with your x to the 19/3 power. Of course, you then have to multiply. And you have to remember there's an imaginary 1 front right here. And so I'm multiplying 19/3 times 1. 19 over 3 times 1. You make it a fraction, 1 over 1. And then you multiply across. 19 times 1 is 19. 3 times 1 is 3. And so this is equals to 19 over 3x. And now I got to find that power. And so I have to take the 19 over 3 and subtract 1. Well, instead of subtracting 1, I see my denominator is 3. And so I'm just going to subtract 3 over 3. Because 3 over 3 simplifies to 1. So I am still subtracting 1. 19 minus 3 is 16. And of course you keep the denominator. And so my new power will be 16 over 3. A nice little shortcut to get to your answer right here is to just think of this division sign right here. This division sign right here as a subtraction sign. 19 minus 3 is 16. And of course you keep the denominator. This will always work because you're subtracting 1, you're always subtracting the denominator over itself. And of course I have to return my answer to the radical form, and so that's 19 over 3. I have the third root of x to the 16th power. Again, if you're not sure, do the little trick. Divide by 3, and that takes us back to where we were. So therefore, this is the correct function. That's number 5. Number 6. F of x is equals to the 6th root of x. It's not written down, but I'll put it in right here, x to the first power. And so again, I gotta transfer this. And so again, a little slash and divide, and the rest goes away. And so my function is f of x is equals to x to the 1/6 power. Again, there's an imaginary 1 at front. And because there is an imaginary 1 at front, I multiply. But multiplying by 1 is not that bad. 1 multiplied by 1/6 is 1/6 x. And then again, nice little shortcut. 1 minus 6 is -5. And so I will have -5, and you keep the denominator over 6. Now I got two problems. I got a negative power, and I got a fraction as the power. And so what am I supposed to do? Take care of the minus sign first. And so then this is going to be 1 over 6x to the 5 over 6. Remember, the negative sign will cause us to go to the denominator. And that is because you're finding the reciprocal. If you reciprocate anything, it ends up going to the denominator. And now I gotta convert my 5 over 6 back into a radical. And so it's 6 times the 6th root of x to the 5th power. Number 7. I have f of x is equals to 3 divided by the third root of x to the fourth power. Well, in this example right here, I first get rid of my radical. So again, divide by 3. And so I have x raised to the 4/3 power. But again, it's in the denominator, and so I got to move it up, switch the sign, and so it becomes 3 times x to the negative 4/3. Now I am ready to go ahead and take my derivative, and so it means I will need to multiply these two together, and so that is 3 over 1 multiplied by negative 4 over 3. Multiply, of course, 3 times 4 is 12, negative 1 times 3 is 3, and of course this divides, and so that leaves me with negative 4. Of course, you could have divided first, slash and slash here, and you would get the same answer, negative 4. And so that's negative 4x, and again, what is negative 4 minus 3? And negative 4 minus 3 is negative 7. And so my new power will be negative 7x to the third. And just like before, negative power, you take care of the negative power first. And so you go to the denominator, so negative 4 divided by x to the 7/3. And then you convert that back into a radical. X to the 7th power. And there you have it. That's your answer. The second part deals with exponentials and logs. So, what happened there? And so that's question number 8. Again, for this section, you mainly need to remember your rules of exponentials and logs. Ln of x, the derivative is simply 1 over x. That's a rule that you need to learn. For number 9, we have f of x is equals to 3 to the x minus 2 times 4 to the x plus 5 times 8 to the x power. First thing to notice is that these two actually are the same thing. They're a different way of writing out the same raised to a power, because after parentheses, exponents are the second order of operation. And so it doesn't matter, both of those are solved the same way. Your rule is you keep the term, so it is 3 to the x, but then you multiply by the correcting factor, the natural logarithm of the base. So that minus, you keep the term, 2 times 4 to the x power times ln of 4. And the last one, 5 times 8 to the x, you keep the term, and then you multiply by the natural logarithm of the base. Number 10, f of x is equals to, oh, that's a y, but it doesn't matter. 5e to the x plus 7. This incorporates two of the easiest rules of derivatives. The derivative of an e is the same, and the derivative of a constant is 0. And so that just leaves me with 5e to the x. Number 11. I have my f of x is equals to 3 ln of x minus e to the 3 plus 4. The derivative here is 3 over x. Again, one of the ways you can help you remember this right here is that what you're doing is you're taking your 3 and you're taking your x and you're swinging the x below the 3. This line ln right here kind of becomes your division. And so it's 3 divided by x right here, and that's your derivative. That's a nice little way to remember what your derivative is. And then, this one's a little bit tricky. But if you look at this term right here, you'll notice that there is no x. Therefore, if there is no variable, this is constant. and the derivative of a constant is 0. So this actually differentiates to 0. And of course the 4 is also 0. And so the answer is actually just 3 over x. It's one of those trick questions they love throwing your way. Derivative of e to the x is e to the x. The derivative of e to the 10 is 0. You got to be more careful. Isn't that how they say? Number 12, I have f of x is equal to 3 times 5. Missing the whole log. 3 times ln of 5x to the 4th power. First, we use our properties of logarithms. When we have two terms being multiplied together, each of them split into their own logs. So that's going to be 3 times ln of 5 plus ln of x to the 4th power. I distribute the 3, so that's 3 ln of 5 plus 3 ln of x to the 4th power. By the power rule of logarithms, I can take the 4 out front and multiply it by the 3. So let's do that. And so that's 3 ln of 5 plus 12 ln of x. And now I am ready to take the derivative. Again, this has no x. So therefore it is a constant. And the derivative of a constant is 0. And my 12x is 12 divided by x. And that right here is my derivative. I don't need to write the 0 down. And so the answer is 12 over x. Last one, number 13. F of x is equals to negative log base 4 of 6 divided by x. Again, I have two terms inside a log being divided by each other. The different property of logarithms says that this will split into two logarithms. Log base 4 of 6, log base 4 of x. I distribute the minus sign. Negative log base 4 of 6 plus log base 4 of x. And now I take the derivative. Again, the first term is a constant. And so it goes away. And then the second term right here, remember there is an imaginary 1 in front of the log. The 1 is the numerator. The x right here goes to the denominator. But because it's a log and not an ln, I have to have a correcting factor. And so I multiply by ln of 4. And that right here is your answer.